Hi there, my name is Martijn and I'm going to take you through a demo of vRealize Network Insight focused on Azure VMware Solutions, or AVS. So most of the demo that I'm going to show you is quite universal, so it focuses on AVS applications in this case, but it might as well be an on-prem application or a public cloud, native Azure application, or maybe even an AWS application. So all of the functionality that I'm about to show you is applicable to all of those clouds and everywhere where you host your applications. And Veer and I will visualize all of that data for you. So I'm going to start off with the application constructs within vRealize Network Insight, and then also talk about discovery, how that does it. And then we can have a look at the application's networking day 2 operations. And then I'll switch to a migration planning scenario where we can look at data that we can use for the migration planning, and then also some data that we can use to monitor the actual migration. So first off, let's start with the applications. So this is a basic list where we have an application name, the amount of tiers that are in this application, so it's a tiered model that we use, and then the members of this application. So this could be VMs, it could be physical IP addresses, so bare metal services, or Hyper-V VMs, for example, that we don't monitor, or Kubernetes services that we do monitor. So these applications come into the system either manually, so you can add them and then give them name, give them an application tier, and then also determine how they are members. So they could be a dynamic membership or a static membership, so you could input the VM name or say, I want all of the VMs where the tag is something. And then once it's saved, you can do a lot of things with these applications. But that's the manual way. The more fun way is to use the application discovery method. So we can discover applications based on existing metadata, such as tags, or pulling it down from ServiceNow. So if there's a ServiceNow CMDB somewhere, we can pull down the application names and the attached VMs. We can use a naming convention, so if the application or the tier name is inside the actual VM name. Or we can use a combination of everything and then also use security groups or security tags. But the most fun way and the most lazy way actually is the flow-based application discovery, where we simply look at the traffic that goes through the network and then form application boundaries based on that. So what happens is that vRealize starts logging all of the traffic flows that go through the network just by getting it from vCenter NSX or the physical network. And then it throws in a machine learning algorithm in order to determine what the actual applications and the tiers are in those applications. One of the examples is this Hive storage server application, which consists of 2 tiers, 2 storage servers, and then 1 video server. And then once it has discovered this, the output is actually just this list. And you can save these applications towards the system, and then you can actually start using them. So I can rename the application here, for example, and then say video, this is the video server, and then I've got 1 tier called storage. And then hit submit, it'll save to the system, and then I can do either day 2 operations on it, or I could do migration planning on it, which I'll get to in a bit. But that's all that you need to do in order to save these applications and discover these applications in the actual network. So nothing needed like existing documentation, existing tags, nothing is actually needed, just the network flows, and Veer and I will suggest all of these applications for you. So once you have these applications in the system, you can do a lot of things here. So I'm going to focus on this AVS application, which is consistent of 3 tiers and 3 VMs, which are hosted inside Azure VMware Solutions. And if I open up that application, I get the application dashboard, which promptly presents the status of this application. So it looks at the incoming traffic, outgoing traffic, the amount of flows, also the internet-facing countries that might be accessing this application. So if the internet is accessing these applications, I would see a lot more countries here. And we have the makeup of this application, like the amount of VMs, the physical IP addresses, or maybe even the Kubernetes services that are attached in this application. There's also some analytics here, like what has been changing in the last 24 hours. So I can see that there's almost been a 50% increase in the last 24 hours. So that might be concern for worry. So I would probably want to see why this is climbing so much. And then we also have application network level alerts in this dashboard. So I can open this up and then I see that there's a bunch of threshold analytics violations, and I can also see like where is that violation. So I can see that in this case the upper bound is 5 gigabits per second, and this is going over it quite much, so almost 8 gigabits already. So this is just an alert that I set on this application, and I want to get an alert every time that these VMs go over 5 gigabit. And I could get that alert via email or via SMP trap. So one of the most interesting parts here is that I've got the application topology, where I could zoom into the tiers, or I can zoom into the communication between tiers. So if I look at this app and database communication, I could get the flows. I could also get the unprotected flows, so those flows that are not protected by NSXT firewall rules, for example. And then see the source destination and the port number that this flow is going over, but also, of course, the traffic graph that actually is going over the network. One of the things that vRealize does, it adds a lot of context and combines multiple data sources into one. So it gets the flow from the network, it just sees a source destination and a port number, and then it starts adding a lot of context, like what is the source and the destination and L2 network, so the NSX segment in this case. What are the source and destination VMs? What are the security groups that are allowing this traffic? What is the source host and the destination host? And if you look closely, you can already see that this is an Azure host, so this is hosted inside AVS. But again, vRealize is very universal, so if a on-prem ESXi host were to be hosting this VM, you would see the exact same view here. Another cool thing is that we can actually see the applied firewall rules for this flow. So in this case, I've got this NSX manager with a default blacklist rule name that allows this traffic. Now, because it's named default blacklist rule, I would probably want to go into NSXT and look at why the blacklist rule actually allows traffic, or that might be for the NSX admins to look at, but at least I can see that this firewall rule is actually allowing this traffic. So if you're troubleshooting a specific flow, it will also show you which firewall rule is allowing or denying a specific flow. I can do the same thing for the other port number, the MySQL port number. It's also quite easy because we give it a name, so we know that this is MySQL. And again, there's again the firewall rule that allows this traffic. So we can zoom into what kind of flows are going from the app to the internet, for example, or the internet to the web. What is the web all talking to, etc. So we also have these alerts, these open alerts, where in this case you can find only the analytics thresholds. And if there were any network devices that were hosting this application that we monitor, so like if it's an on-prem application and we have the switches, the top of rack switches, the routers, the firewalls in there, if there were anything wrong with those devices, you would also see that coming up in these alerts. One of the more interesting parts is also that we supply a security planner, a micro-segmentation planner, where you can see again what types of communication is there. I can also group by another level, so I could go to the VM level or higher and go to the application level, but let's look at the VM level, where then you can see the actual VM name talking to other VMs. And if I open up this slice, I can actually see the flows that are going between this VM and the other VMs. But more interestingly, I can also look at the recommended firewall rules, which in this case on a VM level recommends firewall rules between the shop app tier and then the internet, and it's doing NTP over the internet, as you can see. But also from the web VM towards the app VM over the HTTPS port and 8080, it suggest these file rules because we can see that the traffic is actually going through it. So if you are implementing micro-segmentation for these VMs, I would go in here and export this as CSV, and then I can import that CSV into a firewall system such as NSX. So there's a lot more here, like I could go into the actual flows and then get a top talkers, like which VMs is producing the most traffic. I can deep dive into the metrics. So there's the network graph again. And there's also what's new section here, like in the last 24 hours, what has been going on. So luckily there's no dropped flows or no new members for this application. So if there's a new VM name, for example, that adds itself to the web tier, you would see the members coming up, and also the incoming and outgoing traffic, as you also saw at the summary bar. Right, so if there's a problem with this application, I could go and come into this application dashboard and then show like what are the open alerts, what are the flows that are having issues, how's the security posture, what flows are flowing through this application, and then troubleshoot based on that. Another important part where the application constructs comes in is into the migration planning phase, where we can look at the network data and network requirements for a on-prem application and then figure out whether it can be migrated towards AVS. So for that use case, I've put together a MOAD application migration dashboard, or a PIM board as we call them. And in this case, the MOAD application is just a short name for an application type that we have in this environment. So this dashboard, this PIM board, is scoped on that one specific application. I could also scope it towards a specific network if you are migrating on a per VLAN basis, for example. We've got all of the network details that I would need in order to make sure that this application fits into the network that's on the other side, so inside AVS. We can look at these traffic details to make sure that we don't get any problems when we pick up this application and then migrate it to AVS. So whether that be a problem within AVS or whether that be a performance problem between AVS and on-prem, if there's still a lot of traffic going between this application and other applications that you're not migrating, or end users for that matter. So let's go through this. So we have the amount of total traffic in the last 24 hours. I could also scope this to get a bigger time window, by the way. We have a split between north-south traffic and east-west traffic. So north-south is basically coming from this application going out or coming in, and east-west is inside this application itself. So you can see that there's a lot of north-south coming in, not much coming out. So that's not a lot of egress traffic. East-west traffic, so within this application, is also not a lot. And then we have the maximum rate that's coming out of this application. So the north-south out traffic rate is not even 1 meg. So there's not a lot of traffic going from this application towards other applications. And then we have the average rate, just to make sure that you can scope your data center interconnect based on these values so that it can support these values with the remaining capacity, or maybe you should upgrade the data center interconnect before you actually migrate this app. So I have the security planner here just to look at the topology again, and also I could look at the recommended file rules here if I want to migrate them and then implement the micro-segmentation at the same time. I have the top talker, so which VMs are actually doing the most traffic, and you can see by far it's the front end in this case. And when it comes to cloud, it's also important to know that if it's a internet facing application, where are those internet users located? So VRNI can also help there because it knows where the IP addresses on the internet live, meaning that we can group by country or region or even city if you'd like, for the amount of traffic that's going through this application. So in this case, we've got the UK, which is by far the most traffic in this application. And then Denmark, the US has a little bit, and then Germany, Norway, Spain. So most of it is in the northern part of Europe, northern west part of Europe. We would like to pick up this application and put it into the UK cloud, because that makes most sense, because all of the end users are located near to that cloud. So for example, if you were to take this application and put it in the US, it might affect the performance for the ones that are in the UK, which are most using your application. So why not put it as close to the end users as possible? All right, so here we have the VM metrics, which I also showed you on the application dashboard. But again, you can just quickly see if there's any spikes, or if there's any weird traffic patterns between these between these VMs. But in this case, it's very flat, it's very predictable, as you can see, so that's all good. And then we have a textual representation of the application dependencies that are being detected by vRealize. And in this case, there are no application dependencies, otherwise we would have more applications here. But you can see that just the internet is talking to the shopping cart app. It is talking a little bit to some physical servers, some shared and some regular VMs. But it's not that much, and I could zoom into these related flows if I'd like to and actually get the source destination to see what that traffic is. But again, this is not something that you would very much worry about if you were to look at the migration of this and then scoping the data center and the interconnect. I mean, this is not that much traffic, right? And then lastly, I've got the application topology just to refresh myself on how this application is actually talking and which tiers are there and how are they interconnected. So again, I could do this on a network level. So if I have the migration procedure on a per network, per VLAN basis, I would do the same thing just on a per network basis. The entire PIM would remain the same. It would just be different values. So for example, I would have a grouping by VLAN in this case. And there's just one network supporting this application. Okay, so that's the migration planning phase. Because if you have this information, then you can combine all of these applications into move groups or migration waves and then stick them into VMware ACX in order to actually be migrated. So you would get all of this information here. You would make sure that the network is not going to be a problem when you are migrating these applications or these networks. And then you can start migrating them. We also have a method of moving these application constructs from vRealize into VMware ACX. That's a fling currently out there, which just simply takes all of the VMs and all of the applications that are inside vRealize, or a selected few of them, and then creates mobility groups within VMware ACX. And then you can go into VMware ACX and actually configure the destination configuration for those mobility groups and then start the migration. So you don't have to have a manual copy and paste between vRealize and ACX in order to get to that actually migration phase. When you are actually migrating, you also want to keep an eye out on the network. For example, there's, again, I put together a PIM board for monitoring during the migration. And here I've grouped by on-prem data centers and then the flows going towards a VMware Cloud environment, so AVS. So you can see that the medium here is between 13 and 15 milliseconds, but then you also have a bunch of spikes going double that amount. So there's a bunch of spikes here, and 30 milliseconds is not something that I would personally worry about still, but doubling the latency is quite worrisome itself. So I would go into the flows itself, the related flows, and then I would see what the source destination is. Is it actually going over a direct connect or an express route, which I can see looking at the path that flow takes, and then I can troubleshoot any network devices that are on the way of that path. I could also set an alert, so set a threshold, an analytics threshold for anything that goes over 30 milliseconds, for example. So I would get an alert based on all of these spikes, as you can see here. So that's one metric. Another metric is looking at the ACX, the VMware ACX Layer 2 extension appliances, because they have specific limits that they have, and you don't want to go over those limits. Otherwise, your application performance, your VMs starts doing all kinds of weird stuff, being degraded. It's not gonna make your day if that limit is being reached. So we also want to have a look at the per appliance throughput of the layer 2 network extensions which vRealize can monitor. So you can see that we have a spike here going towards from 30 to 86 megabits per second. And I've actually got an alert here, which is an analytics thresholds alert. I'll show you that specific alert in a little bit because there's also a widget down here, but this is the way that you can add a threshold alert where you can say any traffic going over a specific threshold, I want to get an alert for. And then it also displays that on the actual graph itself. So there's some more network extension appliances here. So each and every single one of them I want to keep an eye out. So these are not doing that much. As you can see, the top talkers is definitely this one. But yeah, I do get those alerts whenever it goes over specific usage. So vRealize is typically used by network admins or VI admins and not the migration folks or the migration centers. But I do want to keep an eye out on how that migration is progressing. So because vRealize has that context of where is a specific application and where are the specific VMs located, so are they on-prem or are they already in the cloud, I can also get a list of all the applications that are still on-prem and all the applications that are already been migrated, and same goes for the actual VM. So which are already on the VMware Cloud and which are still on-prem, so which are to be migrated still. So as the network admin, I would see these lists, so the on-prem list, become smaller when the migration is progressing, and then eventually everything should be on the VMware Cloud. So if there's a problem with any of those L2 extensions, so if there's a flow going on and maybe it's exceeding the threshold that you set on the L2 extension, so if it's producing too much traffic, I could dive into the actual flows that go over those layer 2 extensions. So I could have a look at the top talkers within the L2 extensions, and then also pinpoint the exact source destination that are using up those layer 2 extensions, and then maybe do something about it if something fishy is going on, or move some of the L2 extensions. So here we have the analytics threshold configuration, which I set for the VMware ACX appliances. So this is one-time configuration for all of the L2 extension appliances, and then it'll take them all into account. And as you can see right here, I've got a threshold of 50 megabits per second. And most of them are staying beneath it, but one of them is peaking above it. So this is the same one that you saw in the graph earlier with that alert on the timeline on the graph. So again, if this threshold is violated, you can get an alert based on email or an SNMP trap or just in the UI here. And then whenever the threshold is violated, you could go in and see what the flows are going over that L2 extension, and then take preventative actions before it actually crosses the maximums of these appliances. So we also have visibility into the AWS Direct Connect interfaces, but we're focusing on AVS in this case. So I'm just going to show you the path for the last part, where we can look up network topology paths between two VMs and get all of the network components in between. So in this case, I've got the firewall, the NSX distributed firewall. I can look at the firewall rules that allow this traffic. Well, it's an allow any in this case, not that interesting. And then I've got the NSX router, so the distributed router, the NSX edge. You can see that there's a NAT configuration here with, again, another firewall attached to it. There is also equal cost multipathing available here, so that means that it has a redundant uplink, which you can see if I hover over it, it'll show you the backup link towards the other physical device. So these physical devices are also monitored by vRealize, and if I look at the details of one of these, for example, I could see that it is a Cisco device, a Nexus 7K with this serial number. I can look at the routing table, the router interfaces, all of these things that are important for this path to work. So this goes to another physical device and then comes into a, in this case, an VMC Direct Connect. And comes into the VMware Cloud environment with a firewall, the VMC router or the gateway, and then also the distributed router that is inside this VMware Cloud. And again, if there's any problems in this path itself, it would present itself with an exclamation mark. But in this case, I've got a pretty healthy network. All right, so that was the day 2 ops. And again, there is more information, but these are the ones that we found customers appreciate the most. You also don't want to overload yourself with information. You want to get the right information at the right time. So this is why I've got this spinboard for the monitoring the migration, and then also set those thresholds in order to get alerts whenever something goes over a specific threshold. So now if I go back to the main page, there's one more thing that I'd like to show, is that with all of the features that vRealize can do, there's also a lot inside the actual network. So if there's still an on-prem network available, we have this thing called the network map, which actually ingests all of the information of the entire network and then creates a visual-like topology drawing of that actual network. So I can zoom in and then I can see that we've got an Arista switch here, we've got a Dell switch here, we've got a Palo Alto Networks firewall, we've got an F5 load balancer, we've got a Cisco Nexus device, and it's all connected also towards NSX. And then connected to a specific distributed switch, and then also tier 1 routers and tier 0, the other way around, so tier 1 and tier 0 routers. And I could look into every single of this configuration, look at the entity details, and then get the configuration for this specific router. So whether that be a virtual or a physical router, I could have a look at the actual information on this specific device. So what are the interfaces? Are there any alerts open for this device? So in this case, this is a network best practice health check that we're doing on the network, and which is failing. So yeah, it doesn't matter whether it's physical or virtual, it'll attach itself to each other, it'll build this topology and then create a living network diagram. I could also scroll back in time, so if I want to look at the network map for a month ago, for example, or just a couple of days, I could just go to this timeline and then look at the actual topology of that specific time. Well, in this case, there's no major change, as you can see, but imagine if you are doing a network change and you want to look at the pre-change topology and the post-change topology and see whether the change has been successful or not. So this is a very powerful feature as well. So with that, I'm going to conclude this introduction into vRealize Network Insight, focused mostly on AVS, as I mentioned a couple times, but know that there's a lot more that you can do with vRealize Network Insight, and if you do want to see a little bit more, there are more videos available on each and individual feature, like SD-WAN, like the network map and the intents that we do, the public cloud, the VMware cloud environments. All of that is available within both the YouTube channel and the field demo portal for internal use. But for now, thank you for watching.